Hello everybody. I want to give you notes very briefly on how to figure out the number of protons, neutrons, and electrons that make up all of these atoms that you should now be familiar with. Because we can say there are atoms, but there are also many different kinds of atoms. So you should receive this handout on how to make an atom. And then you should also receive this worksheet where you will practice figuring out from one of these symbols the atomic number, mass number, charge, and then what will become important, protons, neutrons, and electrons. Because these numbers will then allow us to do Bohr models, and then ultimately, especially in the accelerated classes, the ICP classes, we will move on and do electron configurations and then turn those into Schrodinger models as best as we can. So, back to this handout. First thing I want to point out is this will typically be the second thing you do. Normally I will give you the name of what we'll call an isotope that has a specific meaning, but there are many different isotopes of the same atom, and then atoms can have different charges as well. I will give you the name of an atom or an isotope. The number I don't give you when we say those isotopes, I never give you the atomic number. And the reason I don't give you the atomic number, and we're doing zinc there, I hope you saw, the reason is because that 30 is right here on the periodic table. That 30 is the atomic number. We will see that that is the number of protons. This number is called the average atomic mass, and that is different from the other number on our handout that we will see, which is called the mass number. So, let me show you what I would actually call this if we were doing it on a homework now, or a quiz. What I am quickly going to start doing when we are doing these is I'm not going to give you the name. I'm going to give you the name. I'm going to say that this is zinc 65 with a positive 2 charge. That's all I have to tell you. And notice the number of 65 zinc and plus 2, the thing I don't tell you in this is the 30. And that's why you will always receive a periodic table to do any problem with a Bohr, electron configuration, Schrodinger, any of these models and concepts. I will always give you a periodic table. So, I already said that this number is the atomic number. Notice, break that down. That's the number of the atom. The number of the atom for zinc is 30. 30 protons, 30 for an atomic number, and zinc are all the same thing. The 30 is the number of the atom for zinc. They're the same thing. So, what we ultimately are wanting to do is figure out protons, neutrons, and electrons. And notice how I wrote those. I wrote those as P with a plus, N with a 0, and E with a negative sign to help you remember what the charges are on these. So, if we want to know how many protons this has, right there's the answer. It's 30 because that's a 30. Protons is the atomic number. They're one and the same. The next part is we want to figure out neutrons. Well, neutrons are a combination of this and this. It's a combination of this number and this number. Well, this is telling you protons and neutrons. This is called the mass number. And this goes back to the quiz you just took, where you had to identify the mass of protons and neutrons. And protons and neutrons are way more massive than electrons. They're so massive we don't even count the mass of electrons. So the mass number are the two things that have mass. And also the two things that have mass are the two things that are in the nucleus. So all of the mass of an atom is in the nucleus. That's why this is called the mass number. Well, that's protons and neutrons. This is protons. Well, if we want to know how many neutrons there are, then this simply becomes a subtraction problem. And 65 minus 30 is 35. Plain and simple. And this is down here. That explanation of what I just gave you is down here. So mass number minus atomic number gives you the number of neutrons. The final thing is a charge and electrons. That's why this all explains what's going on here. And what I'll do to just give you the shortest version of this, I always tell students to do the opposite. This is the charge. This tells you the overall charge of the atom. And what it's really doing is telling you a comparison of the protons and the electrons. If they're equal, you don't have a charge. If you have more protons, you have a positive charge. If you have more electrons, you'll have a negative charge. So I always say to students, I give them the motto, do the opposite. So if this had been 0, we'd have 30 electrons just like protons, because 30 and 30 would balance each other out. But we have a positive charge. So if the charge is 0, they equal each other. But if the charge is positive, like in this example, and we do the opposite, that means subtract. And if we subtract 2, well, what are we subtracting it from? We're subtracting it from the protons, the atomic number. So 30 minus 2 is 28. And now let's double check. Why does that make sense? Well, let's look at what we have. We have 30 protons and 28 electrons. What do we have more of? We have 2 more protons than we have electrons. 28 electrons have canceled out the charge on 28 protons. They're equal. But there are 2 extra protons, and those 2 extra protons have given us our positive 2 charge. Had this been a negative 2, then this would have been 32 for electrons, and now we would have 2 more electrons than protons, and that would explain that charge. I am now going to pause the video and give you a chance to try the problem at the bottom. So pause your video and we will go over this answer. Alright, we're back, and hopefully you've had enough time to work on this problem. So, looking at this problem, our atomic number, if you look at above, our atomic number is 35. Our mass number is the number in the upper left corner. It is 80. And our charge in the upper right corner is -1. Those are easy. They're all here. Please write 0 if you don't have a charge. It may not be in your symbol, but please write 0 for your charge. Then protons, neutrons, electrons. It's the whole reason we're doing this. Protons is that number right there. It's the atomic number, so 35 is the same as your atomic number. These two will always be exactly the same. Neutrons becomes that subtraction problem. 80 protons and neutrons, 35 of them are protons, so how many of them are neutrons? Subtract, the answer is 45. And then finally, electrons, look at your charge and do the opposite with the 35 because of how important that number is. Do 35 plus 1 and you get 36. And that makes sense because you have one more electron than you have a proton, and that therefore makes that -1. And once again, look how important that 35 is. 35 is protons. 35 or 80 minus 35 is neutrons. And 35 plus 1, 36, is electrons. Without that 35, you won't get any of these numbers and you won't be able to draw a Bohr model. So, take a look now at your homework. Your work, I want you to do this entire front side, and please do not, I beg of you, you are never going to be given a worksheet like this again where you do all the atomic numbers. I know 8th graders well enough that I have seen way too many students over the years just do this column because, oh, it's that bottom number. And then we do this column because, oh, it's that number. But we are never going to do this in columns. We are always going to do this by rows. So it may take you just a few minutes longer to do it this way, but I want you to go across every row because it may take you a little longer, but your ability to figure out protons, neutrons, electrons will be much better if you do it by rows. Thank you very much, and ask me questions in class if you have them. Thank you very much.